live from the Wolfram Technology Conference. I'm Sylvia Haas, and I do the social media for Wolfram Research. And I'm here with my co-host.
Hi, I'm Rachna. I'm a student at the Illinois Math and Science Academy, and I'm part of the Wolfram Emerging Leaders Program. We're here with Tuseeta Banerjee, who's a research scientist at Wolfram, and she's here to talk to us about the Neural Network Repository.
Hi.
So what do you do at Wolfram?
So I work as a research scientist in the machine learning team, and mostly I work in applications of neural networks. So I try to code stuff up in the Wolfram language, mostly important research that's happening out there. So part of my work is researching what's out there and trying to bring the models in the Wolfram language, and then finally making applications for our own functions or adding stuff to the neural net repository. So that's what I do.
Okay, cool. So what are you doing here at the conference?
So I did a course before on Monday, so that was also on mostly about neural net framework and how it was more or less a hands-on tutorial on how you make your own applications, so custom applications. I'm doing this tech talk right now, and in 2 hours right from now, I will be giving another talk on importing neural net models for the repository and talking about the new thing that we have built, that's the ONNX importer. So that's what I am doing in the conference.
Cool.
So tell us about some new things in the Neural Net Repository.
So the net repository is it's a library of pre-curated models. So a lot of our time goes in identifying which models are important and in which aspects or which fields, and then and then coding them up or importing them into the repository, testing them, making sure everything's correct, and making examples so that it's easier for our users to just directly use them. So what's new? I guess I'll be talking a little bit about the most important models, and then I'll be giving an overview of all models that we have added since the last version release, which was in April, and that comes towards the end, and I'll just show flashy pictures of what's there and what we can expect in the near future in next 2 weeks or so. So
So why don't we look at some code?
So let's look at some of the important models that's out there. So a big thing that happened in NLP, natural language processing research, was what's called BERT. So BERT is bidirectional encoder transformer. So bidirectional encoder representations from transformer, but I really like to present it in a funny way. So we take the meme from the actual BERT and then just add a bidirectional friendship because it goes both ways. So the thing about bidirectional encoding means it goes, so if you read text, it goes forward and backward, and that's why bidirectional. So this one was a very famous model that came out, and it sort of broke all the state-of-the-art accuracies. So here is I just put the table of all the kinds of data set and all the kind of tasks where BERT sort of overpowered every other model. So that's why it was an important model, and we decided that we need this model in the repository. So BERT in the repository, so we also introduced what's called the parameterized net models in the repository, since we were seeing that there were exponential number in the number of models that keeps being added, and they just differ by a little bit of parameters. So we decided to keep all the parameters under one name so that it gets less confusing for our users. So as you can see, the BERT is kept as you can call BERT as a net model, and then you can ask for different parameters. So it's these parameters or the different allowed values just directly come from the paper. So it's cased, uncased, large and base models, and also the type of inputs also you can change. So this is how you would ask for parameter information from the net model. Again, I'll be speaking a little bit more about the parameterized net models in my talk, so I'll keep it short. And you can ask for whichever model you choose, so you can have a permutation and a combination of what parameters parameters you ask for. So I'll go ahead and try to explain a little bit about the architecture of BERT. Again, this is one of the more famous and very complicated architecture, so I might not do a very good job in like 2 or 3 minutes, but I'll still give it a try. So BERT again has, so each neural net model in the Wolfram language has what we call a net encoder. That is what, so whatever input data type you have to convert it into tensors. So net encoder is what converts the input type to tensors. So for BERT, it's a text, so it's a natural language processing thing. So you have a text, so you need to convert it into words and subwords, and that's what's done by the net encoder for BERT. Again, this is a custom net encoder, not one of the built-in ones. So we built the net encoder ourselves, and you can just query, you can extract that encoder from the model and play with it or change it for your own applications.
Cool.
So that's the encoder part, and we can just see like what the encoder does. Is you can see it takes the string and converts it into numbers. So there are two kinds of encodings. One is for the word and one is for the sentence. So as you can see, this is the first and second sentence, and it does accordingly. So once the embeddings are done, you can actually do a matrix plot. Not that it makes any sense right now, but you can just visualize the embeddings and all of them. So one thing to note is they have special token for the start and end of the sentence. That's the position, and then you have positional indices as well. So that's all with the embedding. So what embedding does is takes the text and converts it into numbers, and there you go. That's the embedding done. But the main architecture of BERT is what's called the transformer architecture. So that's why it's the bi-directional encoded transformer. So the transformer architecture has, so it's interesting because it introduces a new paradigm of architecture. So that's what's called the attention, multi-headed attention. So the good thing about the neural net framework in Mathematica and Wolfram language is that you can just click and visualize all the complicated architecture. So I think this has more than 800 or so layers, but it is all compressed, and all you see is like little blocks where you can just like click on it, and like a child you can sort of play with it and understand what's the architecture. I think that's what's fascinating about the framework that we have here. So as you can see that each of these have attention layers. In this particular model, there are 12 blocks of these multi-headed attention. Again, if you click on them, you can go ahead and see that they are made with what's called the attention layer. So building these architectures from the bottom up is what we have done to get the model here. But again, here we are trying to show that BERT, it uses self-attention. So there are two kinds of attention. One is self-attention and the other is causal attention. So self-attention, as I was saying, it's bidirectional. So you have, as you can see, you have connections from with both forward and backward in time. And you also have causal attention, which goes all forward in time. So we'll see an example of that in the next model that I talk about. But just to give an overview of BERT, so BERT is one of the best feature vectors that you have. So it's good that I show an example where the feature vector, like we can use BERT as a feature vector. So we are doing a sentiment classification with the BERT embeddings. And here you can see that I'm taking an already existing data set in the Wolfram language. So we have the movie review data set that takes like a bunch of text. So movie reviews, which users have given and classifies them as positive and negative. And what we will do is we will take 3 different kind of embeddings, 3 different kind of models that's already there in the repository. The Clove one, which doesn't have any context. Elmo, which had a context, so it knows from reading the sentences, not just the words, so it has a context. BERT again has context and it is bidirectional, so it learns the features better. So what we are doing here is making a sentiment classification from all 3 models. I will skip the details of the code a bit, just saying that we are using the same sort of code for making the classifier part of it, just the embeddings part of it is different, coming from different models. And as you can predict that BERT being the best feature vector, it achieved the lowest error rate, so it got around 15%, while Clove and Elmo gave around 24 and 19%. So that was the end of 2018, and then we have the next meme where we say, oh, the NLP researchers. So if you don't get this meme, it's like the BERT is here, and then the NLP researchers turn their head or move their attention, which makes more sense here because we are talking about attention models, attention-based models. So they turn their attention to something with unicorns. And if you don't get the reference here, that's also fine. Because when GPT-2 came out, the first blob of text, so GPT-2 was a language model, and then they gave this model a very funny reference that says, in a shocking finding, scientists discovered a herd of unicorns living in a remote, previously unexplored valley in the Andes mountain who happened to speak English, who happened to speak perfect English. And then they let the model just output what it had, and the output of the model is pretty funny. So I wouldn't be able to read that out loud because of time constraints, but I ask everyone to go and read that. It's a funny thing that they got. So what I did here was to take the reference and modify the example a bit to get outputs here. So we'll take the GPT-2 transformer, the larger one. Again, GPT-2 is placed in the same way as BERT. So I wouldn't go into the details, but I would just show the language modeling aspect of it, which is important for this model. So it's very similar to BERT. It has encoders. Technically, they are different, so they use different kind of encoding function, but we are not going into the details. It uses BPE subword to do its encoding. There is still the positional index, there is still the token index. The vocabulary is a bit bigger than the BERT model, and the only difference between BERT and GPT-2 is what we are saying. The BERT was an encoder, the encoder transformer, and GPT-2 is a decoder transformer, and the difference is the kind of attention. So BERT had self-attention, this has causal attention. So that's the difference, and I have pointed the difference in pink because they had all unicorn references. So, and then we go ahead and do text generation with GPT-2. So I just take the GPT-2 model and give what's called temperature. So temperature is something which, so if you think of the entire vocabulary as a distribution, temperature says how flat of a distribution you're sampling from. So if you're sampling from a thinner distribution, then your temperature will be lower, and if a flatter distribution, the temperature is higher. So here we just show examples. I just took the same thing and modified it a little bit. Just took away the names of the mountains and just modified it a little bit to show what happens if you change the temperature and the sampling of it. So that's what you get. And again, they make it makes so it just continues it and says, according to the team, 50 unicorns lived in 16 rectangular structures that range from 15, which I didn't let it finish. So as you can see, if I increase the temperature, it becomes a little bit more weird. That's what we expected. And then when I decrease the probability, it says, the researchers also found that the unicorns were able to communicate with each other through their tongues, and that repeats because it's sampling less of a distribution. So that's what happens if you keep less temperature. It just gets stuck in the same. It gets stuck in a loop. So that's the more important models that we had.
Awesome.
We have some other little models that I can just let go. As I was saying, that we have introduced the parameterized net models. So the reason why is because we were seeing a lot of different models. So these are just a glimpse of other models that we have. So this is a segmentation model for biological image segmentation. This is a resolution enhancement model. This is a sentiment analysis model. So that's also based on LSTMs before encoders were a thing. This is the mobile net model. So these are much smaller models than it was before, and this is a PPE model, and I think this is an audio model. Wolfram audio identify model that we had brought in 12. So these are just a list of different models that we have right now in the pipeline, but these are something to be which is either in the repository, we are curating it, or we are in the process of getting them out. So we also encourage our users to submit models to the repository. So that's why I put the last slide here. It's because all of these models, the 4 models you see here, were not done by us. They were submitted by our users, and then we curate them and make sure it follows our standards, and we add them to the repository. So I encourage all of you to submit models to the repository.
All right, thank you so much for coming in and talking to us.
And
Coding needs more unicorns in it.
Thank you for having me here.
No problem. Have a wonderful day.
You too.